Okay, Unit 7, Part 2, Logarithms. As you can see from the dates on the table of contents, we are off a tad bit. So we're going to make an adjustment to this because I will try to attempt to do 2 lessons in one day. So today is 22nd. We'll just go ahead and change this right here date and just write that this is going to be 422 and we'll do intro to logs. Okay, so again, change your date here for pages 1 and 2, 422 intro to logs. All right, so there was a reason I gave you the bell work I gave you, because I needed your brain to go thinking about exponents, because logarithms are just another way of writing exponents. Now, this is what we call logarithmic form. It's read as log base b of a equals x. What this essentially means in exponential form is your base to your exponent equals what number? In other words, you're going to take your x and your x becomes your exponent. Get it? And the a becomes the answer. So when you look at the exponential form, it's essentially saying, okay, I've got my base, and the exponent is the value of the x, which will equal the answer. Let's see how this goes. Write each equation in exponential form. This equation says log base 3 of 9 equals 2. What this is saying is 3 is my base, and to what power will it equal 9? Well, it's saying 3 to the second power equals 9. If you recall, the number here is our answer, meaning it's the number that goes with our x. It is our x. And if you put this in the calculator and check it, you will see that this is in fact true. This one says log base 6 of 216 is 3. What this means is here is your exponent. 6 to the third power equals 216. That's how you would write it in exponential form. The next one, this is saying log base 7 of 1 is 0. This simply means 7 to the power of 0 equals 1. All of these you can put in the calculator and check and see. They all will be true. I'm sure by now you might get the hang of things. All right, so this one here, we've got our base, log base 2, meaning that's going to be my large number. And the answer is the exponent, so that's going to be 2 to the fourth power equals 16. Look at what happens when you have a fraction. If you recall from simplifying exponential functions, we know that when you have a fractional value, that there was a negative exponent involved here. And this is actually found to be true when you're looking at logarithmic functions, because 4 to the power of negative 2 is equal to 1 over 16. And you can put that in your calculator to check that. All right. And this one is basically saying 9 to the power of 3 over 2 is 27. And all of that is, in fact, true. If I were going from an exponential form back to logarithmic form, this is where I'm going to put the word and state the base of the number and what it equals. So if you recall, the way we went from logarithmic to exponential is that we kept our base as the larger number and we moved the value on this side to be our exponent, and it would be set equal to our answer. So if we were going in reverse, this would be log, and the base is still going to be the same thing you see, 14, because 14 is my base, but it would be log base 14 of 196 equals 2, because 14 to the second power is 196. This one in logarithmic form would be log base 3 of 81 is 4. Log base 12 of 12 is 1. Log base 36 of 6 is 1/2. Try the next two. Okay, I hope you paused and checked to see what you got. I wanted you to try those first on your own. And if you did, then this is what you should have got for number 11. And number 12 was the log base 8 of 16, which was equal to 4/3. Now from here, we are going to begin to evaluate logarithms. There are two kind of logarithms we're going to evaluate. We're going to evaluate the common ones and then the ones that involve a change of base formula, because to get the answer to the logarithm, it's going to be a little bit harder because it's not something that we can calculate easily in our head. A logarithm with the base 10 is called a common logarithm. Okay, and this can be written without the base. So log base 10 of x is just simply equal to log x. How does that help us? Well, we're going to use our knowledge of what we know about exponents to evaluate the following logarithms. If you recall, when you read this, it says log base 7 of 49. Well, it equals x. In this case, what this is saying is log base 7 of x is 49. What must x be so that 7 to that power could be 49? Well, x would have to be 2. Okay. This one is saying log base 3 of x equals 27. That means x would have to be 3, because 3 to the third power is 27. And all of these, I really want you to be comfortable with checking by putting it in your calculator just to make sure you're doing it correctly. All right, so this one is giving us log base 10 of x equals 100. Now, that means 10 to what power will give me 100? Well, we know that would have to be 10 to the second power. And the next one, log base 12 of x equals 1. Anything to the power of 0 is 1, so we know x has to be equal to 0. All right. Now let's try the next one. Log base 2 of what value equals 64? Well, that would have to be x equals 6. And again, if you want to put this in your calculator to check, you can do so. This one is log base 3 of x equals 243. So that means my x would have to be equal to 5, because 3 to the fifth power is 243. I see a fraction, which means I know I've got a negative exponent coming up. This one is saying log base 9 of x equals 1 over 81. Well, we know that 9 to the second power is 81, but 9 to the negative second power would be 1 over 81. And the last one is log base 64 of x equals 4. Whenever your base is bigger than your value over here, this means your exponent, your value for your x, is going to be fractional. Okay, so if I wanted to find this, I'm asking myself 4 to what power would give me 64? Well, I know 4 to the third power gives me 64. So that means I would have x to the 1/3 power to give me 4. And if you ever check that, you would just, take your x here and you can put 1/3 in the calculator, and 64 to the 1/3 power would give me 4. Some logarithms aren't as easy to do and require what we call the change of base formula. When this happens, we simply use our calculator to calculate it, and we are going to take whatever we have for our log base of A and divide by our log base B. So in this case, if I were trying to solve this, take and keep in mind that this is basically saying that I want to know 16 to what power would give me 64. There is not a whole number that we know of that will give us this. So when this happens, all you have to do is simply use your log button in your calculator. I'm going to write it down first, and then I'll show you how to enter it. You will write log of 64 divided by log of 16. Okay, and let me show you how to put that in your calculator. Clear this out. So we're going to type our button that says log, which is over here by the number 7, and it was 64. You have to close your parentheses. If you don't, you won't get the correct answer. And you're going to divide by log of, 16. We find the value of our x to be 1.5. Now, when you look at that, think about it. Does that make sense? Well, if I were to put in my calculator 16 to the 1.5 power, would I get 64? Well, let's see. Go back to the calculator. 16 to the 1/4 power is, oh, I didn't mean 1/4. Sorry. 1.5. Let me do that again. 16 to the 1.5 power is 64. So in this case, we see that that does work. We are able to find that missing value, that logarithm, by just using this function. So that answer again was 1.5. That is the missing value we need to get 64. Again, here we see we've got a log base 8 of what power to give us 32. Well, that's not going to be able to be done in your head. So we use the change of base function, which requires that I take my log of 32 and divide by log of 8. And again, I'm going to use the log button on my calculator. Press log 32, close your parenthesis, divided by log of 8. Notice we get a repeating decimal, and we're going to leave it as a repeating decimal here. So I'm going to write that my answer is simply 1.6 repeating. All right, the next one, just like the rest, really straightforward. We don't know what power rate 2 would have to be raised to give us 54. So we're just going to simply take our calculator for the log function of 54 divided by the log of 2. Pause the recording and go through to solve each problem on your own, and then come back and see if you got it right, okay? For log base 54 of 2, you should have 5.7549. For log of 294 divided by log of 10, you should have 2.4683. The next one, you should have 3.5 5437. That's kind of sloppy. That's 5437. And the last one is -2.